Welcome to the future. It is here. We are in the age of AI. And we know this because Bill Gates told us so almost exactly a year ago today. And just think about all of the amazing developments that have happened in that time since. How many of you have started using ChatGPT? Yeah, pretty much everyone, right? I mean, it has changed the way that I know I work and interact with folks. In fact, my 12-year-old son goes to it on a pretty regular basis, asking it questions and getting higher quality answers than I myself could provide. So the age of AI is here, and it's already having a pretty profound impact on the way we work. In fact, 2% of the workforce has been displaced already, and 38% have found their jobs to be fundamentally disrupted by AI technologies. And we're still in the infancy, right? But this isn't the first time we've gone through this. This isn't the first time we've had these periods of mass disruption. And in order for us to understand what's coming next, we really need to look at where we've been in the past. So this is a beautiful visual timeline from the Edison Institute on innovation cycles. And we've outlined 6 different phases that we've gone through in recent years. The first one beginning in 1785 with the introduction of water power, which paved the way for our factories. And then we can jump fast forward to the 1990s when Bill Gates was part of bringing software to the masses, right? And now, today, we are connected for the first time in human history. We can talk with people all around the globe. We have the rise of the smartphone, which has only been 17 years. And I'm looking around this room and I can see folks have been alive a lot longer than that. So you remember a time before smartphones. And think about how it has changed everything from the way that we interact with each other, the way we shop, the way we do our work. This 6th wave is going to happen even faster and have an even greater impact on society than the ones that have come before. And this has been the trend, right? But this one is going to bring with it clean power, clean energy, robotics, and artificial intelligence to I hope, help us rectify the mistakes we've made in the past. So who am I? It's a bit of an existential question, but for the purposes of this talk, my name is Michelle Winters, and I've been working with data and nothing but data for the last 25 years. Big data, small data, and everything in between. I got my start as a database administrator at GoDaddy before I went on to lead their data engineering and analytics infrastructure team. Did some cool things there, and then went on to Netflix, where I led their data engineering core and big data tools team. Did some more cool things there before I went on to found Noteable, which was my first startup focused on collaborative data tools based around Jupyter notebooks. And the idea there was that I thought everybody, all companies, should have access to high-quality collaborative tools, even if they didn't have the really incredible 9-figure data budgets that these big tech companies had. And so that company was acquired last year, and now I'm at eBay. And I'm there to help modernize their end-to-end data infrastructure because I believe with every fiber of my being in the necessity, the absolute need for a more sustainable future. I should say real quick, disclaimer, the views here expressed are mine and mine alone. They do not necessarily represent my past or present employers. So with that out of the way, let's talk about data. What is data, right? I think of data as a digital representation of what is physically taking place in our companies, right? And so this could be interactions between customers and our software, or it could be our systems themselves. That data is used to help us make better business decisions and to build better products and experiences for our customers. We've been doing this for a while. It started with our transactional systems, where we wanted to look at reporting and just try to answer the question, what is happening? Or what happened, right? What happened? And we found this to be really valuable, but we wanted to really be able to get deeper and understand why did it happen. So this gave rise to our business intelligence departments, right? And we found great value in being able to get into this diagnostic analytics and being able to explain why did something happen. So we started to invest in our predictive analytics, and we had our data science teams come onto the scene, and we started to do more forecasting and look at what is likely to happen next. And of course, the next obvious thing for us to do was say, well, if we know what's coming next, what should we do? What should we do to actually help achieve those business results, right? And so this was where machine learning came with our prescriptive analytics to help. And now we're at the very dawn of our next phase of analytics maturity with cognitive analytics, where all of the questions go out the door. There's no more what, whys, and hows. Instead, there's an intelligent agent actually assisting you, saying, let me help you with that. Let me help you with that. And that might feel a bit off-putting at first, but if you think about it, what we've been doing for these last many decades is really, we've been a bottleneck to the organization trying to be able to answer their questions. The business has tons and tons of questions they want to understand so they can make better decisions, and we've been really barriers for them, right? We've not been able to get to all of the data, all of the questions that they have, and so now they're going to have the ability to be able to have a virtual assistant actually sitting beside them, explaining to them what the data means and helping them make better decisions. And as we move up these levels of maturity, we see that the business value continues to grow, right? So when we look at this, cognitive analytics is not even the end all, right? We actually want to go back to the very beginning, back to our descriptive and diagnostic analytics, and we want to get out of this reactionary mode of explaining what happened in the past, and we really want to understand and be able to explain what's happening right now today. What is happening today? Why is it happening? What is the real-time impact of that issue? And better yet, how can we fix it? And my favorite, let me help you with that. So this is the foundation of what it is that we're doing when we think about analytics. And you cannot skip through these levels. You cannot just jump through one of these levels without making solid investments in them, because you can't really explain why something happened if you don't have a good foundation of what's happening today. And you can't really have really great predictions if you don't understand why something has happened in the past. And so we have to continue to invest in each of these levels. So let's talk about some of the new technologies that are helping us do this, helping us get there. I call these quote unquote new because these have been around before, but they've been more specific use cases, and now these are becoming a lot more generalized. The first one are our graph databases with our knowledge graphs, right? And so we use these to explain things like the relationships between things, complex multi-dimensional relationships that are far more intricate than the relationships we can describe with our relational databases. This could be things like your product data, your customer data, or your account identity resolution, right? So these knowledge graphs are a key foundational piece on how we're actually making AI work. Another piece are our vector databases, which allow us to take these complex documents and images, and even our graph databases, and flatten them into these arrays of numeric values. And because we can flatten them into these numeric values, we can now start to apply math to them and look for the distance between these items. And now we have the beginnings of our semantic relationships and being able to say, using algorithms such as our nearest neighbors, KNN, what is the closest image to this other image that I'm going to provide to you, right? So this is another foundational piece for AI. And then the third key technology change that I'm seeing is really Kappa architecture. So we've had Lambda in the past, which allowed us to unify our batch and our stream processing, and that was great. But it came at a cost, because now we had to manage both of these, and we had to reconcile the two different systems. And so Kappa just moves all into streaming. And if you have to reprocess, you're just working from that same stream processing system. So how does this interact with LLMs, right? Well, when we look at our LLMs, we're using our knowledge graphs to fine-tune our foundational models. And then conversely, we're using our LLMs to enrich our knowledge graphs. So we get this beautiful symbiotic relationship between the two. We leverage our vector databases for retrieval augmentation generation. We go in here and we say, I have this question or this prompt, I'm going to embed it into this numeric value, and then I'm going to go look into my vector database for the items, the context that is closest to it in meaning, in semantic meaning. And then I'm going to provide that back to the LLM so I can enrich it with real-time context. So my LLM is great, but we have sometimes challenges with hallucinations or it not quite understanding what it is that we're trying to do. So when we provide this additional context, we get higher quality answers. And then we have LLMs interacting with our Kappa architecture. So we have a need to have all of our feedback data coming into the systems real time. And we might not be refreshing our large language models real time, but we do want to have real-time understanding of, what's the feedback? Is there suddenly an issue? Do we see a lot of negative feedback? That might indicate a degradation in the LLM and we need to take action. And then conversely, as data is coming in through our systems, we want to embed that and store it into our vector database so that when we're doing our searches, when we're trying to provide additional context to the LLM, it is grounded in the most recent view of data available to us so that we're retrieving the best answers possible. All right, relational is dead. Long live relational. I've been hearing this for the last 15 to 20 years, that the relational database engine is done. And so I recently went on to DB Engines. I don't know if you've seen this site. I think it's great. They'll give you a view of all of the various engines out there and rankings in terms of popularity, and you can see how things are evolving over time. And they also break it out by different types of models or modes of databases. And what you can see is this is a complete view of the 20 most popular database engines out there. And our relational databases are still very firmly entrenched in the enterprise. They're not going away anytime soon because they are where we store all of our transactional data, anything that requires high guarantees, order management systems. These continue to live in your relational systems. And whenever scale permits, we actually want to co-locate as much data as possible. So we've seen that our relational engines have become multi-model, where we've brought spatial data and graph data and vector data into the relational store. That's not always possible for us to have it co-located, but when it is possible, we do definitely prefer that. Something else I want to call out is there are 418 different database engines out there, and this number continues to grow. I don't expect to see this number changing anytime soon because what you find are there are a lot of purpose-built solutions depending on the industry you're working with, the data you're working on, the types of needs that you have in your organization. So you will not hear me talking about any specific database technology because I do believe the answer is always, it depends. So let's look at the modern data stack, right, and all of the components that exist today. The first we need to look at are the personas served by it. In the past, it has primarily been our various analytics departments, but we are seeing a continued movement of our operational teams and our product engineering teams moving into the analytics stack because they have a need for analytics as well. We've been talking about on-prem and multi-cloud and hybrid for a moment now, but we are starting to see an increase in our edge computing needs, right? So edge computing is going to be your IoT systems or your CDNs or anytime you've got autonomous vehicles or autonomous systems, you want to bring your systems to your data. So this is your edge computing. And so we're going to see this continue to grow in coming years. And then we've got our storage and compute. We continue to be bottlenecked on storage and compute. This has been an age-old story for a while now. Data continues to grow at phenomenal volumes. That's not slowed. It's only continued to grow. And ideally, in a perfect world, we would like to be able to store the data once and have a variety of computational engines live on top of it. And so this is the trend that we're starting to see, or that we've been seeing. Data lakes and data marts and lake houses and active warehouses, all of these things continue to be very real. They're not going anywhere. And one of the questions I had heard was, what about data marts? Do we still have the need for data marts? I'm actually only seeing data marts grow, especially as we move towards decentralization. Zhamak in her talk on data mesh, really described it well. And so each of these departments are really creating their own data marts, and then we have a need to unify them, and that's where you're seeing that happen in our lake houses. And then we have the rise of new technologies such as graph, as I just mentioned. So we're continuing to see graph grow in popularity and feed this into our LLMs as we try to organize our data and get beyond some of the technologies that we used in the past. They were the best technologies available to us. But now we're finding, now that we have graph databases, maybe there's a better way to express our relationships than the one we've used in our relational databases. And then micro databases. I don't know if you've heard of this, but I heard about this recently, and I'm actually excited for this concept, which is essentially a data lake of one. So you can imagine if you've got a smart home and you have all of these sensors that exist in that smart home and you've got accounts and payment information, all of that information really relates to a single customer. And in a micro database, they would have their own database, their own data lake, where all of this information is co-located so that you can get much higher performance if they're trying to do analytics on their own systems. But also, let's think about it from a governance perspective, right? If you want to be able to understand this data, or if you have a need, the right to be forgotten, right? It's a lot easier to clean up this data by just dropping that micro database. Data products continue to grow. Data products in the past have been more of our dashboards and our reports. And now we're seeing this continue to extend in terms of data itself can be a product. or you can have models be products. And then these are really the interaction points for the business, right? So we see the business interact with the data products, but we also see our engineering teams interact with the data products directly too. So as we move towards this idea of decentralization and data mesh and more scalable foundations, one of the things that really enable all of this is a data fabric, right? And so the data fabric provides cohesion across this entire environment. Let's talk about some of the components that exist within it and how it's going to evolve in the coming years. Data security. Data security has always been important, but our bad actors are getting increasingly intelligent as they leverage AI to impersonate people. So we have to get beyond policies. We have to get beyond our back, and we really need to be able to look for anomaly detection and look for unusual behaviors in the way that people are accessing the data so we can intervene immediately. Data governance, again, an increasingly important topic. We want to be able to understand the data. We want to protect the data. We want to think about it from a data privacy, and also be able to assign a taxonomy and a set of rules that we expect all of these various data marts to be able to adhere to so that we have commonality across them. So it doesn't matter where the data is created, we have consistency between all of the various systems. And then metadata management, right? And so we want to have greater visibility into all of our metadata. We want to have it in a single centralized location. And we want to go beyond just, semantics. Semantics is incredibly important, and we need to do a lot of work to flesh out semantics. But we also want to think in terms of, costing and utilization. Who's using this data? How's it being used? What is the kilowatt hours and the cost of this, right? And that feeds into all of our automation abilities. Queries. We want to have a single place where we can query across multiple database engines. And we want our queries to be intelligent. I want you to be able to write the SQL for me, right? So write the SQL for me, and better yet, tune it for me whenever that's available to you. And so this is going to lower that technical barrier to entry when you're not able to serve all of the data needs that you have in a report or a dashboard or a prepared data product. We still want to be able to support queries. We just want to do it in a more scalable fashion. APIs and SDKs are going to be ways that people continue to access our data environments programmatically, but it's also going to be the ways that our systems interact with them. And then caching. We really want to be mindful of our computational resources. And so whenever possible, we want to be able to have intelligent caching. I'm excited to see what AI can do to help with things like cache invalidation. All right, so data engineering. Let's talk about our pipelines. This is going to be an area where I expect to see a lot of automation. When it comes to our data transport and ingestion, we really shouldn't be spending time doing that. Somebody still needs to find where you want to move your data from point A to point B and all of the variables around that, but the actual data movement itself should just be happening for you. And when we think about transformations and data preparation logic, we should really be thinking in terms of reusability. If we've implemented data mesh, we should have data experts who sit alongside our source data teams, so we're not creating the mess that everybody has to clean up afterwards. So the work here should be lessened, and whenever we do have reusability, we should have libraries that really encapsulate that reusable logic, so we're not having to reinvent the wheel each time. And then intelligence will help us to find those functions and apply them at the right times. Lineage. Lineage is one of those big foundational connecting pieces where we want to be able to go, outside of just our data lake house, and we really want to be able to understand lineage from the source systems into the data marts, into the lake house, into our reports, but also into our models, and then back into the applications. And lineage is only going to continue to increase in complexity. I mean, I don't know how many of you have seen these really complex DAGs, but they only continue to grow as you want to add more consuming systems to them. And then quality and data ops is another area that I think is really going to be improved by data intelligence in the coming years. Data quality continues to be a challenge where it's very reactionary, and if you either don't have enough quality on it or you have too much quality and you're getting false alerts, and either way it's not good and you're not having good business outcomes. And so what sort of models can we build to help us better understand the quality of our data? And better yet, let's actually get that into our CI/CD processes so that as we're writing our pipelines, we can have really good regression tests, and then we can actually have really good detection. And when we detect a problem, we can get on top of it right away. And if we do have to reflow things, that the reflow has become autonomous or at least semi-autonomous remediation there. So I'm excited for all of that. We need data orchestration to tie all of these things together. really in a cohesive way. And then our asset catalogs. We want to get beyond thinking about just data, and we want to think about every single piece of the puzzle that goes into bringing these things together in an intelligent, and scalable way. We want to have really rich discovery experiences on top of this so that you can easily find the right data assets to be able to serve your need, and then really intelligent exploration and semantic process to help you understand what it is that you're looking at. All right, I tried to create an architecture diagram that would show you where everything is moving to. And I spent a lot of time on this. I came up with about 6 or 7 different views. And I realized all of them were crap because there is no one-size-fits-all anymore. There is no one-size architecture to rule them all. It really, really depends on your environment. It depends on if you're open source or vendor locked. It depends on the industry you work on, the types of compliance issues that you have, the types of investments your companies have previously made. I'm going to make a completely different suggestion on your architecture if you've invested heavily in an enterprise data warehouse appliance versus if you are mostly sitting in a data lake and it's uncurated. So I think the real key here is that as data professionals, our roles are evolving. We are no longer thinking about just trying to follow, one paradigm, and instead we need to come to understanding so we can really guide the business to the decisions that are going to be best for them. All right, so let's talk about the proverbial elephant in the room. I've touched on a few things that might have made some folks nervous when I talk about cognitive analytics, and let me help you with that, and transport and movement are going away, and we shouldn't really have to spend as much time on pipelines. And these things are all true, right? And it's coming very quickly. So what does that mean for our jobs? Are we gonna have jobs in the future? Do we need data engineering? And the answer is a bit uncomfortable. The answer is it depends. It depends on where you work. It depends on the type of company that you're in. How do they view data? Are they primarily focused on profit at the expense of quality of experience? Are they focused on data as a cost center? If so, they're going to want to cut cost. Is your role primarily data movement from point A to point B with no real ownership and no real ability to influence anything? If the answers to any of these questions are true, your job might be at risk. The interesting thing here, though, is that the data consistently shows us a high correlation between quality of experience and the ability to increase profitability long term. And so you will find that for every company where they see data as a cost center, there are many more that see data as a profit center, who understand that data is a key way of improving quality of experience, and they are investing in it. I cannot say enough good things about Netflix and their data-driven culture and the investments they've made in data. I think they do an incredible job. But when I think about will our jobs be automated away from us? Is there a need for humans? I go back to a story from my Netflix days with Stranger Things. Netflix has made incredible investments in their models. They focus on customer joy as their key North Star metric. And so they look, whenever they're looking at content, to see, is it filling a gap in their content portfolio? Is there something that they could do they have enough quality content to serve all of their members, essentially? And when you look at the data was inconclusive about Stranger Things. We had enough mystery and enough nostalgia. We had enough of each of these individual genres. But at the end of the day, it wasn't a machine or the data that was responsible for the decision, it was a person. And the person had some context that the data did not. They understood how they felt when they read that script. They understood that this was really a genre-bending series that nobody had really seen before. And so they made the decision to greenlight that. And what a great decision it was, because it ended up going on to be one of their biggest hits, brought in tons of new subscribers. And I think this model is going to continue to exist. We are going to leverage data to make better and more informed decisions, but at the end of the day, we are creating products and services for people. And I believe there's always going to be a need to keep people in the loop. But I do think our jobs are going to change. I think they're going to change quite a bit. And I think the work that we do today is going to look very different a couple years from now. For starters, there's going to be a model for that. There's going to be a model for all of it. Whether we're talking about creating queries in text to SQL, or whether we're thinking about insights and how to find the insights, how to understand it, how to visualize the data. There's going to be a model for that. There's even going to be a model to write the models, right? We have these already today where they can go in and do semi-autonomous interrogation of the data and come up with really strong and often unexpected insights into our feature engineering, right? But at the end of the day, Google has this idea that anything that you care about, you want to have a single responsible individual owning it. And we really, really care about the data. The data is what fuels the AI. And so we are going to need people to own the data. One of the things I think we're going to see is the rise of data product owners. Data product owners who own the pipelines themselves, who own the data from origin to consumption. They understand before the data is being written, why it's being written, what the meaning of it is. They ensure we have a strong semantic layer. They're going to all of the downstream systems and consumers and letting them know, hey, this data is going to be available, and you might have these uses for it, right? So they are going to be responsible for overseeing the data as an asset. Then you're going to have your data engineers really bifurcate into two key distinct roles. One is going to be your domain-aligned data expert, someone who deeply understands the domain. So if you're in marketing, you understand attribution. If you're in finance, you understand SEC rules. If you're in healthcare, you understand the rules that apply there. That knowledge has value. And we want people who understand that knowledge, who are working with the models and going end to end. I no longer want you focused on a task, I want you focused on objectives. And I want you to use these models to go end to end with those objectives. And then you have the third, the data artisan. And I call them artisans for a reason, because when you talk to the best and brightest software engineers, they will tell you that software, and I believe data, is part art, part science. And the models are here to help us with the science part of things. So we need people to help with the art, people who understand. And there are going to be people who specialize in each one of these tasks. When I talk about intelligence, that's not going to automatically happen. We're going to need somebody who is more versed in Python and Scala, who are actually writing all of the base level components that allow us to get to automatic query optimization, right? Or if we're looking at higher quality storage algorithms, we need someone to do that evaluation. And so there's still going to be roles for there. You're going to have less data artisans, I believe, than you are your domain data experts, but they're going to be incredibly high impact to the organization. So yes, I do believe that we are going to have jobs in the future, but I do believe that we're going to be undergoing a transformational shift in thinking in the way that we approach our work. We need to get out of the tasking mode, and we need to get more into an ownership model. All right, so let's talk about the future of data. The future of data is trustworthy. It's funny to say this because we've been talking about data trust for a while, and yet I cannot tell you the number of people I talk with, and you ask them about their data environments, and they say, yeah, we've got a lot of data, but only maybe 10% of it is what we would consider high-quality, trustworthy data, right? And all data in your company should be high-quality, trustworthy data. We should understand what it means. Meaningful. Well, we should have data that we understand the meaning of, right? So this is where we get to that really rich, strong semantic layer, which is the key enabler for all of the cognitive analytics and everything we want to do around automation and self-serve. It should be efficient. We cannot afford to waste our resources. Physical resources continue to be very expensive, and they have a very real impact on the environment. So we want to make sure that when we're running jobs, we're doing it as efficiently as possible. Distributed. We've been moving towards this model for a while now. Zhamak was just talking about how we have distributed data teams in our data mesh, and this is going to continue to grow. So this is the expectation. It's not going away. We're going to continue to work in distributed fashion, and then we're going to have centralization when and where we need it, where it makes sense. Connected. We are going to have, even though we have all of these siloed data marts and siloed product teams, we're still going to have this idea of federation across them. You should be able to federate your queries and pull your data together in an efficient manner. Collaborative. We get the best results when we work together in teams. Another Netflix example for you. I was talking with the leader of the experimentation team, and they said, Michelle, it turns out humans are actually really, really good at prediction. We are very good at predicting what somebody would like if that person is exactly like us, or if they share enough demographics in common with us. But most people are not like us. And so as you want to move into a more global enterprise, you really need to think more globally. You need to have more diverse perspectives. And so when you have these teams of diverse individuals coming together, they're going to see things that you might not see. And so the expectation is that when we work on data, it is done in a collaborative fashion. Impactful. Everything needs to tie back to business impact. And so as we understand how things cost and what their actual impact is and how they're being used, we can make sure that we're deprecating the things that are not adding value to the business and focusing more on the things that are. And then finally, ubiquitous. So data is going to be everywhere, and I mean everywhere. When I say that, let's circle back around to where we began when we talked about this 6th industrial revolution. We are just at the dawn, and there are 3 key technological trends that are really enabling this. The first one is quantum computing. I don't know if you've heard the latest, but we are now at 158 million times faster than today's supercomputers. 158 million times faster. I struggle to comprehend that. I struggle to understand what that's going to mean for us once we get quantum computing to a mainstream technology. The second one is graphene. My kids are so tired of hearing me talk about graphene because I am just in awe of this material. It is the material of the future. At 1 atom thick, it is based on carbon. It is 100 times stronger than steel. It is impermeable to gases and to liquids. It is invisible. It is flexible, and it is the most thermally and electrically conductive material we have. This is the material of the future. It is going to be our spacecrafts, our robotics. It's going to be woven into our fabrics. It's going to be in our shoes. So as we're walking, we can understand, do you need to do any sort of adjustments to your gait? We can take the heat from our body and fuel our cell phones. This is the material of the future. And then we have AI running on our quantum computing, running with all of this new sensor data where everything really has the potential to capture data. It's going to weave it all together in an incredible way. So I want to leave you with this. After Noteable, I took 2 years off, and I really did a lot of soul searching and a lot of reflection, and I was thinking about the future and what comes next. And I did not start in a good headspace. It was a bit of a doom and gloom outlook for me at the time. And I started talking to everybody and educating myself and looking at where we are today and what's to come tomorrow. I talked with people from every walk of life, and it doesn't matter if you're a billionaire or if you're homeless. We're all essentially saying, things are not okay. We are not okay. And when I look at all of the problems facing us today, I see AI as a key enabler to all of those, as something that could fix it and be part of the solution. I mean, think about it. If you could have an intelligent assistant in your ear as you're having a conversation with your child, with your partner, with your colleague, and it's correcting your tone, or it's saying, hey, maybe we should revisit that comment and talk about your childhood traumas later, right? Think about how we could evolve as people and really start to become a better version of ourselves. So I believe that AI is part of that solution, but I don't think we just get there. I don't think it's just a guarantee that we're going to have a better tomorrow. I think it's every single person in this room making a decision to build for a better tomorrow. The data people, because this is the foundation of AI. And I'm not just saying this, I'm doing this myself. When I looked at my next job, I didn't go to the sexiest company. I didn't go to the sexiest job. I didn't take the highest paying role. I went to the place where I thought I was actually making a difference, being part of the solution. And so my ask for you is that as you reflect, especially if you have any concerns about the future, take a good hard look at what you're doing, where you're working, how you're living, and ask yourself, am I part of the solution? And if not, take a step back and see how you can maybe make some adjustments to build towards a better tomorrow. So that is my talk. Thank you for listening.